Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the cryptography challenge, Polycrypto. Let's get into it. Polynomials are a very useful branch of mathematics. They can also hide secrets. Can you find what this one is hiding? Then they give us a Mega NZ link to download the challenge file, as well as a Wikipedia link to look at in regards to what this challenge is about. So let's go ahead and open up the Mega NZ link to see what kind of cryptography that we're dealing with. As the challenge suggests, this is some kind of polynomial cipher. And if we go back and look at the Wikipedia link, we know this has something to do with finite field arithmetic. If we scroll down, we can kind of see how it works. As you can see here, we have a polynomial similar to the one that we see here, only much more simpler. And we can see how this polynomial is converted to binary and then hexadecimal. Now you can read this Wikipedia article if you want to get more in depth with it, but basically what each of these exponents in the polynomial represent is a place in the binary number. What do I mean by that? Well, this 6 here represents the 6th place in the binary number. Remember, we start from the 0th place and work our way up. 0, 1, 2, 3, 4, 5, 6, 7. Then we have x to the 4th, which would be this one right here, 0, 1, 2, 3, 4. And then x to the 1st. Obviously, you can simplify it and not have the 1 there. So the 1's place is right there. And then plus 1 represents the 0th place because x to the 0th power is 1. So whatever numbers are represented in the exponents indicate which places in the binary number represent 1s. That being said, we can take a look at our ciphertext here, and we can quite clearly see that these go all the way up to the 206th place. So that's going to be a pretty large binary number. Now, we don't want to do this all manually, so we're going to write a little script to do it for us. So what we're going to do is copy this polynomial out to our script. Then we're going to clean it up a bit. All we care about are the exponents because that's all we need to actually solve this challenge. So we're going to do Control-H to find and replace. And we're going to look for space plus space x caret. And we're going to replace all those with comma spaces because we're going to convert this into a list of integers. We'll do replace all. And then you're going to clean up the last little bit here. We'll call this list poly, and we'll surround it in our brackets here. And we'll clean up the end here as well. Now remember, 1 represents the 0th place, so we actually want to convert this 1 to a 0 as x is not represented here. So x would represent 0 in binary because there is no x to the 1st power being represented by this polynomial. Now that we have our list, we can actually start decrypting our ciphertext. So let's start by creating a for loop. And we'll do for I in range. And since we want to work backwards from our highest exponent to our lowest exponent, we'll start at 206 as our beginning index. Then we'll go to -1 because we want to go 1 less than, or in this case, since it's a negative number, 1 more than -1 is 0. And then we want to decrement by 1 each time. And then all we're going to say is if our index is in our poly list, then we're going to create a binary string. We'll just call it binary. And we'll just add 1 to our binary string. Because remember, anytime our index matches one of the exponents in our list, that indicates that that is going to be a 1 in our binary string. Then we'll just do else, binary plus equals 0. So we're just going to add a 0 onto our binary string anytime our index is not actually found in our poly list. Then at the end, we're going to go ahead and print our binary string. And we'll go ahead and run that and see what happens. As you can see, we quite clearly get a binary string back with no errors. So this is hopefully going to be the binary conversion of our polynomial expression. That being the case, let's go ahead and start converting this to ASCII. What we can do first is convert it to a decimal integer, like so. And then we'll do my usual method. We'll convert that to hex. And remember, you're going to want to shave off the first 2 bytes because those will be 0x. And then we're going to do bytes.from hex, like so. And then at the very end here, we're going to do .decode. That way we get a string literal rather than a byte string back. So this should work. We'll go ahead and run that. And there's our flag. Polynomials are cool. So we'll copy that. Paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below, and leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.